Hello everyone and welcome back to another video here on the Automation Insight channel. In our last video we did a code along with me video with the factory IO scene called From A to B Set and Reset. In that video there was no talking going on, it was just me solving the whole scene in one video. So I promised that I would do another video where we rewatch the episode and I just talk during the coding, and if I find it necessary to pause, I will also do that. So I have not prepared anything special to say. I'm just gonna watch it and I'm gonna take everything as it comes, and hopefully you find it useful to listen to what I have to say. So yeah, let's start the video. Okay, so the video has started and we are starting off inside of factory IO. So I start by opening up the scene from A to B, set and reset. And I start by just testing everything out here, like manually. You can, you see on the left hand side in the top left corner, I can see all my inputs and my outputs. And even if I have not connected any software to factory IO, I can always play around with the inputs and the outputs. And yeah, I think it's a good common practice to test things out. And like I'm doing now, I'm actually renaming some of my outputs just to give them a name that I'm comfortable with to work with. Factory IO will always have their default names, but I find it more comfortable to take my own names. And yeah, you can play around, maybe experiment with the machine. You want to know how things work and so on. So next step is here I am going to connect the software. And as you can see now, I'm going into configuration. I'm actually going to pause here. I'm going to rewind the video and I'm going to pause here. You can see that I have 3 inputs and 1 outputs here. And the scene actually has only 2 inputs and 2 outputs. And this can be modified in the configuration tab, which I will do right now. So watch this. Here you have 3 inputs and 1 output. So I just change it to 2 inputs and 2 outputs. And then I simply can drag my inputs and outputs like so. So let's see what I do now. It's actually been 2 months since I did this video, so it's interesting to see to me what I'm doing as well. So I'm starting up here. I'm gonna pause the video. I'm starting up the virtual PLC, and like I explained in my first video, you have to name it factory IO in order to get the connection going. So start. So with my virtual PLC running, I should be able to connect the factory IO. Right now we can see that it's blinking red. So I press connect and there we get the green check. Perfect. So I'm going to go ahead and create a new project. Project A to B. So the first thing I do here, this is something that I talked about in my first video. I can actually rewind here and just give you a quick look again. I right click on the project file here, and I go to properties, and then I go to protection, and I check the box support simulation during block compilation. And you always need to do this if you are going to simulate your PLC, otherwise you won't be able to compile program. That's why I do it. Then I go ahead and add my PLC. And you can just go ahead and choose the same PLC and the same version as me. I also talk about this in my first project, I think it is. Or maybe it's in my first video, I can't really remember. So the next step here is to add my signals from Factory IO into TIA Portal. And this is a good common practice to make two tag tables, one for the inputs and one for the outputs. This is a very small project, so we only have 4 signals in total, but it's still good common practice to do this, to separate the inputs and the outputs. And in this project, you can see that I'm writing, I'm adding the tags manually. There is a function, I'm going to pause the video here. There is a function where you could copy all the signals and then just import them into TIA Portal. I will show that in later projects when we get some more tags going, but it's very good to know how to add signals, because they have to have the right data type and the right address in order to work. So you can actually see here, I think I'm going to change this, because you can see here that this address is not correct, because this is the enter conveyor and it's an output, not an input. You can see here the address is 0.0 and a Q, which is output, and this is wrong here. So I'm probably gonna change it here. Let's see. Yes, I do change it. And if you don't change it, you will just the signal won't work. That's the thing, like the program won't work. So important to make sure that's correct. And now I'm doing my first download to the PLC. So the things I've done here, added the PLC, adding the tag table, I'm gonna download it so that we have the correct version. And I'm probably gonna check that the signals are correct. And that's also a good common practice to do. Verify your signals before you start the actual coding. So here I show that the virtual PLC is up and running. It's green. And here I'm going to check my signals. So we can see here, I'm going to pause the video again, and we can see here that our sensors are working. So the stop sensor is true and the start sensor is false. A good thing to bear in mind here is the sensor type here is normally closed. So that means that when there's nothing in front of the sensor will actually give you a 1, a true. You can see both sensors now are true. And if I rewind the video here a little bit, you can see that when the box is inside the sensor, I pause now, it goes false. Yeah, it's called normally closed and normally open sensor. It's easier in our head. It's easier actually. Like if something is in the sensor's path, it should be true. And if you want to think like that, to make it easier logically, you can invert the signal when you're actually going to use it. And I will actually do this in this video, and I always do it for just making programs easier to write. So I will show you how to do that when we come to that piece in the video. So now when I know that my signals are working, I go offline and it's time to add some functions. So I start by doing one input and one output function. Let's see what we do now. I'm creating one conveyor logic. Okay. I'm doing one database for the conveyor. And I also did a folder. So this is also very good common practice to keep everything organized. So this is my, I'm going to pause the video here, and this is my starting point. I did 3 functions. They are all empty right now, but I did the input and the output and the conveyor logic. And I put them in the main cycle block. So right now there's nothing there, but this is the common way to, you would like to read your inputs in the start, and then you would like to do all the logic, and then you would like to set all your outputs. So the inputs always come first and the outputs always come last. And I make sure to comment everything, even if it feels a little bit too much, like why do I have to write everything, comment everything, but make sure to do this always, because it will help you as you progress your programming projects. Alright, now I'm inside of the conveyor logic database, and I'm just making some structure in here as well. As you can see, I did 3 structures with inputs, outputs, and internal. And this is like, you can think of this of like the inputs that the conveyor logic function needs is gonna come to the input section, and if any outputs are produced, they will go inside of the outputs folder, and the internal folder is used for when you need something inside of the function, like only inside there. I tend to put them in the internal folder, and I usually always do this like folder structure. Sometimes I don't use everything, but I prefer to have it there by default so I can use them. And if you wonder why I type random stuff inside the structures, it's just because that in TIA Portal a structure cannot be empty. If it's empty and you try to compile, you will have an error. So I just do a random placeholder just to make sure that the structure is not empty. And I could go so much more in depth on some of these things I do, but the video would be so long. So I'm just gonna talk about the things that comes to mind. And if you have further questions, yeah, just ask them in the comment section, and I will try to answer them. So what I'm doing here right now is I'm just preparing this function with some variables, because what this is, you see, I did the start sensor, the stop sensor, and I did both my conveyors here. And these are just empty variables right now that I'm gonna connect my signals from the tag table eventually to these variables. That's how it's preferred to work, because if you can work with variables, you can do a very flexible and nice program. So right now these are just empty placeholders, and I will try to explain more when I'm gonna do the connections. Don't really know what I'm doing here. I turned off the force on the conveyor, so make sure that nothing is running by force. And I realized that I had the input and output in function block, and I prefer them in ladder. So you can actually change language inside the function, and you can have different languages in different functions. So what I'm doing now is, you can see that I'm gonna pause here now when I'm finished. So inside my input block, I took the actual sensor, like the actual sensor tag from the tag table, and I give it a variable. So whenever this sensor becomes true, this variable will also become true. So in an instance, you can see this as a what do you say? This is a representative of the actual value. You can have multiple variables. Maybe you have 3 functions that needs the start sensor. Then you can just add all these signals here. So I'm going to do the same here now to the outputs. And when you do the outputs, that is in reverse order. So you always have the output on the right side, on the output side. And by that, I mean that in the input, we are actually looking at the sensor, and when something happens to the sensor, we will write the same thing to the variable. But in this case, we are this signal here from the variable. If it's 0, nothing will happen. But if we get a 1, a true, on one of these variables, that will activate the conveyors. Let's see what I'm doing right now. So I'm gonna download again. You can see here, I'm gonna pause real quick. You can see that all these dots that are not green, that means that you have a difference in the online version and the offline version of the PLC. So I have made changes inside of the portal, and that is the offline version. So they don't match with the online version of the PLC, and that's why I have to download again to update the PLC. So that's what I'm doing now, and you can see that all the dots become green. And here you can see, let's see what I'm gonna do here. I think it's time to invert the signals. Yes, here I'm showing you that what I said earlier, the sensors are normally closed, which means that they will give a signal, and you can see that on the stop sensor. The stop sensor is over here, and there is nothing interfering with that, so it generates a true signal. And when I put the box in front of the start sensor, it will generate a false, a 0. And this can be very complicated to develop logic around, because you have to think in reverse. So the easiest way to do is just to invert the signal. You flip the signal, and I think I'm gonna do that now in the video, if I remember correctly. Yes, so that's the normally closed symbol. So I just changed that, I download, and now you can see the result here that both generates a 0, but when we get the box in front, we get the true. It's much more easier to develop functions and logic when you have the signal correct. Okay, so I'm gonna do two networks here, one for the entry conveyor and one for the exit conveyor. Okay, so I have used now some stuff from my database. So what I have done here is that I decided what is going to set my latch, and it's the start sensor. And to reset the latch, I need a signal on the reset sensor. And if this start sensor is true, then this is gonna latch and activate this on top of the function, which is the output exit conveyor. So it's a very easy way to control an output. You decide what will activate it, and you decide what will reset it. So here I'm just doing the same thing. And that's not the correct one. It should be the start. Am I using the... Okay, so I actually need to pause here and see what my idea was. Okay, so I'm actually saying here that if the exit conveyor is not running, then the entry conveyor should be running. And I'm saying that if the exit conveyor is running, then you should not be running the entry conveyor. So that's the logic of the entry conveyor. And let's see if I'm gonna try this in action probably. Then we need to download the code again. Okay, so that kind of worked, but not really. So the problem that I encountered here is that I said to start the entry conveyor, the exit conveyor must not run. So when we start the scene, the entry conveyor starts to run, and then the exit conveyor has this command that if you detect a true signal on the start sensor, which you can see here is true, then you shall start the output conveyor. The problem here is that since we start the output conveyor immediately when we detect the signal, then the entry conveyor will shut off, as you can see here, because the exit conveyor is running, therefore the entry conveyor should not be running. And you can see the problem here. I'm gonna rewind a little bit. You can see that the exit conveyor is actually running, but it can't really get it over the line because, yeah, the entry conveyor needs to keep running in order for that to happen. You can see it here up close. And that's a problem, of course. We can't have it that way. I don't know what I'm trying to do right now. Trying to flip some signals. This is the upside of doing things in a simulation. You can just throw things around, try things around. Nothing will break. So what I will end up doing here is I will use something called a flank memory or a trigger. I don't really know what's the correct word in English, but yes, I do know. It's called a rising edge or a falling edge. So what that means is, so I'm gonna pause here real quick just to try and explain it. A signal can be true and it can be false, 1 and 0. But if we use rising and falling edge, we can tell the program, I'm not interested if it's true, I'm only interested when the signal goes from true to false. So that's called a falling edge. So I want to detect when I lose the signal. So I think that's what I'm going to do here. Yes. It's called a negative flank, or yeah, falling edge, rising edge. And this is a function already like done by Tia Portal, so you can just drag it in. And what I did here, I put the start sensor on top of it, because on top of it they want the sensor that you want to detect the rising or the falling edge, and then you just need like a variable to store it in. So that's why I did this internal flank memory, so I can save it. So this should work better. Let's see. That's better. That's much better. So the thing is here, I paused the video now, and when the box is inside here, the sensor area, we have a true signal on the start sensor. But what this new thing that we added here, the falling edge, does, it keeps track of when that true signal becomes false. So watch now, as the box leaves the sensor, the true signal will go to false, and then this latch will reset, and that will turn off the entry conveyor and put on the output conveyor. It works perfectly. And I think that's I think that could be the project done. It seems so. Yes, only 3 functions: input, conveyor logic, and output. Thank you for watching. Perfect. Okay, so to summarize this video, it is a bit longer, almost 30 minutes, but some concepts I try to explain to you, since this is the beginning of this course, and this series of projects that I'm going to try to do here on the channel. And as I progress up the projects, I'm gonna start maybe not explaining so much of the basics, and take that for granted that you know some basics. And of course, you are always welcome to ask questions to me in the comments, or yeah, like so. So with that said, thank you for this video. I hope you enjoyed it and that you maybe learned something. And if you still are wondering on something, just let me know, and I'll see you in the next video.